What's up, y'all? It's Mr. Riley. I'm going to go through a video on how I solve and how I recommend solving quadratics using the square root property and best of all, completing the square. I think this is an easier way to complete the square than some of the other tutorial videos on the internet. So here you go, Mr. Riley's way of solving by completing the square. Now, the first thing you need to do is determine whether or not you need to even complete the square to begin with. So first off, you probably ought to ask yourself, is there 1x, right? Because if there's 1x, like this problem, you can just go and do the square root right away. Or if it's something like x squared, plus 3 equals 10, you can subtract the and then take the square root of both sides. You just isolate whatever is squared. But if there's more than 1x, you can't do that. You're going to have to do some kind of factoring, right? So if the answer is no, then you need to ask yourself something else. Can you factor into the same factors squared? Is it a perfect square trinomial? For example, over here, whenever we factor this one, we're looking for something that multiplies to 81 and adds to negative 18. Well, it turns out that's the same number twice, right? Negative 9 and negative 9 add to negative 18, and negative 9 and negative 9 multiply to 81. So this trinomial can factor into a perfect square, x minus 9 squared. That, unfortunately, does not happen with this one. If I factored this as it stands, we would be looking, a lot of these aren't even going to be factorable. This one turns out to be factorable, but it's not helpful, right? Multiplies to 9 and adds to 10. Well, that's going to be 9 and 1, but you'll notice these are not the same factor. And because they're not the same factor, we just can't do that. It's not set equal to 0. This is going to give us a bad answer. It's not solvable that way. So if the answer to this question, can you factor into a perfect square, as it stands right now, the answer is no, then we must complete the square. So without further ado, here's what we're going to do. Step 1, we want variables on one side, constants on the other. So what that means is that anything without a variable has got to go. You'll notice I have two terms with variables. I've got x squared and 10x over here, but then I also have this constant, this 9, right? Anything without a variable is a constant, and I am going to subtract 9 from both sides so that that is no longer there. Now watch how I write this equation next, because I'm getting ready to complete the square. I'm going to create a new trinomial over here. I've got 24 minus 9 is 15. I'm going to create a new trinomial over here that completes the square. That creates this one, my new trinomial, will be factorable into like parentheses squared. So I'm going to insert a number right here. Now here's the deal. I'm dealing with an equation. So whatever I add here in order to maintain balance in the equation, I need to add to the other side as well. So this is our regular addition property of equality. Whatever you add to one side of the equation, I need to add to the other. In the exact same way that earlier I subtracted 9 minus 9 became 0, but I had to subtract 9 on this side as well. So if you're dealing with an equation, whatever you do to one side, you have to do to the other. So if we're adding a number, I have to add that on the other side again, just to maintain balance. So here's the question, what is that number? Here is how I do that. We use the area method or the box method to figure this out. I am going to put my first term in the upper left corner, okay? Because I know that x squared is going to be x times x. Here's what I'm going to do with the other one. I'm going to take my second term and I'm going to split it in half. So 10x, just split it in half. That is going to be a positive 5x and another positive 5x. You can use that information now to fill in the rest of your factors. Because if this, in order to get x squared, this has to be x and x. In order to get 5x, this has to be a 5. And in order to get 5x on the other one, this also has to be a 5. X times what gives me 5x? Well, that's going to be a plus 5. And you'll notice that we now have the same factors, x plus 5 and x plus 5. Here's the deal. We are missing a number. We have x squared. We have 10x, 5 and 5 is 10x. We don't have this number. So that is what we are going to use to literally complete this square. It's a box, it's a square. We're completing it. We need this number. And that is easy as just doing 5 times 5. That number is 25. And that is what we are going to add to both sides of this equation. The left side, we know, is going to factor down into x plus 5 squared. The right side is 15 plus 25, right? Because we had to add 25 on that side too. That's going to be 40. And now we're moving forward. Now all of a sudden this problem, through this process of completing the square, looks just like this one, right? All we got to do now is take the square root of both sides and we're moving. Okay? So, to recap, move your constants all to the same side and then figure out what is the third number that needs to be here in order for this trinomial to be a perfect square. Okay, and that's where we complete the square. We split that middle term and we just kind of fill in the outside. It's all pretty straightforward because in order to get x squared, these have to be x's. In order to get 5x, these have to be 5's. Now, it's just filling in this last piece. There it is. Now we have a trinomial that factors into x plus 5 and x plus 5, or x plus 5 squared. And we can move on. Now we got to solve this the rest of the way. I'm going to use the square root property to take the square root of both sides. Because taking the square root of something squared, those are inverse operations. They cancel each other out. So that leaves me with x plus 5 equals the positive and negative square root of 40. At this point, I would like to simplify my radical. 40 is 4 times 10. 4 is a perfect square trinomial, so in essence, I have the square root of 4 times the square root of 10, so that can be rewritten as the square root of 4, which is 2 times the square root of 10. So I can rewrite this as x plus 5 equals positive and negative 2 times the square root of 10. We have one more step. I don't want to know what x plus 5 is. I want to know what x is. So I'm going to subtract 5 from both sides. The plus 5 and minus 5 cancel out, leaving me with just x. And on the right side, here's how I'm going to write this. I've got that negative 5. The negative 5 does not interact with that 2 root 10. Those are not like terms. This has a square root of 10 attached to it, so I can't do like 5 plus 2. That just doesn't work. So what I'm going to do is I'm just going to write it like this. I'm going to put that negative 5 or that minus 5 out front, and then plus or minus 2 times the square root of 10 is coming after that. And ladies and gentlemen, that is our final answer. Okay, with that, I really hope that it was helpful. I hope that you learned something with this. Come see me in class if you need any help. And with that, I'll see you next time.